welcome you all to the Spark Research YouTube channel. This is Dr. Vijendra, Assistant Professor in the Department of ECE. So this is the another series for this course, Analog and Digital Communication. Code is 21ECC302. So we are going to now take this course and we will complete this course, right? So in this session, we are going to take the parts from the unit first. Particularly, we'll focus on the analog modulation technique. So here is the syllabus, and we are going to take the contents from this particular course only. So we will talk about the need of modulation, types of analog modulation, amplitude modulation and its types, then the generation of amplitude modulation waves, and how can we detect like linear method to detect collector modulator, and non-linear method that is balance modulator, and lastly we'll see about the how to demodulate the modulated signal using the envelope detector. So first question is that what is this modulation and why exactly are we talking about this modulation, right? So suppose here is a y signal. So y signal means your m of t, that is called the message signal, right? So whatever currently I am the generating the some sound wave means I am speaking, so that is also considered as a message signal. Why? Because this the information contains the some message. So this is your m of t, this is your y signal only. And now if we want to the transmit our voice signal to longer distance, 1 kilometer, 1,000 kilometer, then the our voice signal cannot propagate, so it needs the some support. So like how can we transmit for a longer distance? So exactly answer is that there should be some carrier who can carry this information, so that is called carrier wave. So of course this our voice signals have very less frequency, that is why it cannot propagate to the longer distance, but carrier frequency may have the higher frequency, and if higher frequency, definitely it can propagate to the longer distance. So here you can see the frequency is very less, and here you can check the frequency is very high. So normally the masses, your sound wave may have the frequencies in the range of 100 to 300 hertz, but for carrier wave, right, your frequencies may fall in the range of the megahertz and even sometimes of gigahertz. So this is the difference, right? So it is a process of verifying the characteristic of high frequency carrier is varied in accordance with the instantaneous. So now question is that how will you modulate? Means how will you load your message information into the carrier information, carrier, right? So that is called the modulation, right? So with the help of modulation, like we are going to load our message information into the carrier wave. Now how it can be done? So we'll see exactly the how we can perform the different types of the modulation technique. So that is best. And the transmitter in the form of the audio, video, text, computer, pictures, like all these are the application for transmitting the information. Okay, so some more important the application, that is why are we using this modulation. So like if you will check, then if you want to transmit the the information to a longer distance, and if you are using the low frequency signals, then in that case you need very longer antenna, right? So in order to avoid the antenna size, we are going to use the higher frequency. So if your frequency is higher, in that case your antenna size will be reduced. Why? Because antenna height can be found using the lambda by 2. Lambda is your wavelength, right? So you can, if you are the changing the wavelength, that is if you are reducing the size of the wavelength and increasing the size of frequency, since lambda and frequency both are inversely proportional, then automatically your antenna size will be reduced, right? So as for example, if frequency is 1 kilohertz, antenna height may require the 150 kilometer, but if your antenna, your frequency is 1 megahertz, then your antenna size will be only 150 meter, right? So right now all of you are using a mobile phone, and definitely it also contains the some antenna, but you cannot find the any antenna like longer antenna. Why? Because of the simply the higher frequency is being used here. Okay, so one more application, that is multiplexing. Also, this is the one of the important reason behind using this modulation. So what is this multiplexing? So used to translate different signal to different locations with the same channel, right? So we can have the one channel, that is air is also an example of your channel, but problem is that you cannot send the same information, different information with the same frequency. Right? Why? Because it may have the crosstalk and you may not be able to deliver the information to the destination. So in order to avoid this, just assign the different frequency like 1 hertz, 2 hertz, 1 kilohertz, 2 kilohertz, 3 kilohertz, means different frequencies for different information. And then if you are going to detect the information with the different wavelength or different frequency, definitely you will detect the all the information. So this is called the multiplexing, right? All right, so here is the now classification of your analog modulation scheme. So your modulation can be divided into the two types like continuous and then pulse modulation. And then under the continuous wave modulations, mostly we are going to talk about your amplitude modulation, then the angle modulation. So amplitude modulation, under this umbrella, we are going to learn three different types of the amplitude modulation, that is double sideband suppressed carriers, SSB that is single sideband, VSB that is vestige sideband, right? So we'll see all these, and these pulse modulation, these are also the example of your analog modulation technique only. Okay, let's see the some examples. Okay, so before going ahead, means exactly we are going to talk about the amplitude modulation. But before going to talk about the amplitude modulation, these are the some basics about the Fourier transform, which must be remembered. Otherwise, you may get confused that how are we doing the calculations related to the modulation technique, particularly amplitude modulation. Right. So what is the Fourier transform? Fourier, using the the Fourier transform, you can change any function in from time domain to frequency domain. So that is called your Fourier transform. So suppose ft is a any functions, the distributed in time domain, then f of omega means the Fourier transform, that is means we wanted to convert in the frequency. How much? F of t into e to the power minus j omega t dt. So if you will integrate over minus omega to omega, you will get the Fourier transform of this f of t. Now you may ask, sir, why are we converting from time domain to frequency domain? Why? Because very simple, your ft means your example of your m of t, that is message signals, and message signals may have the the long range, means your, if you will talk about the time domain, then if I may start to speak from any instant to longer instant. So you cannot we cannot uh, the solve the questions in the time domain. So in order to avoid this complexity, we are converting into the frequency domain, because frequency of any speaker will be same throughout the time. So this is very easy. So that is why. So f of omega can be find out, and then frequency shifting properties. What is this? So now if you have the f of t to the power minus j omega t, and then if you will convert into the frequency domain, then simply your frequency will be shifted by minus of omega naught. So f of omega minus omega naught. So what are we doing here? We are multiplying with this e to the power minus j omega t, right? So remember this property we are going to use. So for example, here is your f of t, like something like exponential, and so f of omega will be how much? You can put f of t is equal to e to the power minus at here, and you can get the values here. So this will be your f of omega, that is your frequency Fourier transform of this function. Now you can again you can shift it by the frequency domain, like multiply f of t with the exponential of j omega t. So by using this property, what will happen? Your frequency will be shifted. right? So here it is your f of t to the power j omega t, and here is your transform, right? So you can see here now your frequency is being shifted by the omega minus omega naught, so it is distributed from here to, right? So in this way, the your frequency shifting property will tell you how to shift the frequency in the frequency domain using the Fourier transform. Session. Thank you for joining the sessions. If you have any doubts, please drop your comments. We'll come with another session related to the frequency modulation.